guys, we're continuing now. Let's see. Okay. So we have one trig lesson left, and then it's on to another chapter. So what we're having a look at now. On which page?
62 and 4.
What?
3a and 4.
What are we talking about? No, next week. Next week in the tutorial.
Yeah, but we never did it.
I know. I'm giving you new challenges you haven't seen before to test you as a person. You know. I'm sorry. You don't have much of a choice. Okay. Okay, so we're having a look at trig graphs. Ahmed, please listen. Oh, come on, guys, come on. 64. Amjad. Come on.
I'm really excited about it.
Ready? Yeah, okay. So we're having a look at trig graphs now. So first graph we'll make is the graph y equals sine x. We can use degrees or radians, it doesn't matter. So let's just use degrees. I think some of you might have seen this graph before. Yeah. We'll say that's 360 there, that's 180, that's 90, that's 270, that's 1 and that's minus 1. So the graph goes up, back down at 180, then at minus 1 at 270, and back at 0 when it gets to 360. I'm sure you've all seen this before. The graph repeats itself as well every 360 degrees. Do you remember the word from sequence and series that describes a repetition like this? What is it? Come on. What is it? What's it called? Yeah? What is it? Periodic, yeah. Periodic. Vibrating? No. No. Right, so if you can draw that one, that's the sine graph. So let's have a look at the cos graph. Oh, Mariam, I've noticed you're picking up very bad Dublin habits. Yeah, I saw you crossing the road, and you did that Dublin thing where you cross the road, there's traffic going around you, and then you continue crossing. Yeah, it's a very bad Dublin habit. Yeah, would you do this back home? Oh, really? Oh, I see. Okay. So you feel quite at home here then? Yeah. Okay. So cos x now. No, you see, the reason I say this, my wife's American, so the first time she saw people doing that, she's like, you can't cross the road when there's cars coming. I'm like, I know, it's okay. You just go a little bit, then you wait, then you go a little bit more. No problem. Okay, so the next one now is cos x. Oh no, that's a totally different.
No, it's a talent to cross the road.
Oh, it is, yeah, and light brisket as well, I think, yeah.
There's actually
Traffic lights are only suggestions, aren't they? Yeah. It's optional to stop at red. Yeah.
unless there's traffic.
Yeah. Well, even that I don't know. Okay, so the next one is cos x. So what happens here is, well, how's cos x different? Who knows this one? It starts from 1, yeah. So it'll go down, it'll reach minus 1 at 180. and then it'll be back up at 1 at the end at 360. And this also repeats every 360 degrees. Okay, so the next basic graph to do, you could probably guess, is what would you do, cos? What's after this, do you think? Tan. This one's a bit peculiar. So tan x, every 180 degrees it hits 0. So that's 0 as well. So if I draw kind of dotted lines every 180,
Looks like multiple repeating this.
yeah, it spikes, and then spikes again, like this, and then I suppose it would have, it would have spiked there as well. So it has these spikes, and these spikes, the 0 is every 180, so there's a 0 there. Oh, sorry, I misspoke. The 0 is every 360. Interestingly, if you type tan... Oh, no, sorry. Don't draw that. I screwed it up. Thanks for the gas. This adds to the excitement. It spikes. In my picture, I had it spiking in the wrong place. You can keep the picture, you just need to change the numbers, okay? So this is still 0. I should have marked off 90, 180, 270 and 360. So just being carefuler now. It spikes at 90. Okay, and then the next time it spikes at 270. It passes through 180, spikes at 270. That's how I should have drawn it. So the zeros are 180 apart. The spike happens at 90 and also happens at 270. And it repeats like this. The next spike, is it? Or the next 0? The next 0 would be at 360, 180 again, yeah. So, like that then, yeah. Now, I don't worry so much about the tan, because they've never asked for tan in the exam, and I don't think they ever will. It's sine and cos that they like to ask. But they don't just ask for a simple sine and cos. They have more in it, like sine 2x or whatever. So we need to study now how the graph is affected by having different constants in it.
If we were to, if the question was to graph this sine graph, okay, like 3 sine, whatever, do we have to represent it within degrees, or can we represent
They'll
it?
say it in the question to use degrees or radians. If they don't, just use degrees. It's kind of easier. Okay, so let's have a look. There's a couple of transformations to look at. So we saw what happens if we have sine x. So the first situation now is what happens if we put a number in front of sine x. How does the graph become affected? So if that's sine x, what is the effect of having a number in front of the sine? How does the graph alter? Yeah, so how would you describe this? It's like the graph has been stretched vertically. So it looks like this now. Okay, so it's like A times taller. So if the A is 2, it's now twice as tall. So it doesn't stop at 1, it stops at 2. If it's 3, 3 times as tall. Peaks at 3.
So it can't be a negative?
I will deal with negative at the end. We won't worry about that just yet.
Maybe like 0.5 or 0.2.
Yeah. So if it was 0.5, what do you think that means? Yeah, yeah. Okay, that's the first situation. Is that? Now I want to show. I'll show you that here. Look. So let me just fix that. Sorry. Right. So there's our sine graph. Okay. If I make it, let's say, 2 sine x, and I graph this, what you get stretched now? See? The peak is at 2 now. Okay. I hope we're all happy with that, yep? So the next situation now.
So normally what you're saying is normally they don't give us a question of like x, we give them as 1.
Yeah, yeah.
That's wavelength.
Wavelength is the next one now. Yeah, well that's what we're looking at next. So next now, if we have a b here. So there's our sine. What's the effect of having a b here? Like if it was a 2, does anyone know? Wider? Twice as wide? Yeah, that's it. So what verb would you use? Yes. Any verb? Squished is fine, yeah. Squished, compressed. So it's actually narrower. You get twice as many. So instead of being like this, you'll have 2 of them. So it compresses by b. Now let me show you. So there's sine x. Now here is sine 2x. Compressed. You have more of them. Now people get confused and say, why is it more not, like, why does this happen? Well, think about it. If this is a 2, what's going to happen is you're going to reach 360 here sooner, because you only need the x to be 180. So it's like you accelerate the loop. Right? Right.
And if you do the opposite, it would expand?
If you have b as a half, it would expand. Yeah.
So that's very good.
Okay. Continue.
And does that also apply to the coefficient of sine itself? With the peak
Yeah, that's what or somebody, I don't care. I was saying, if it's a half, it compresses for the A. 3. If you have, let's say, minus here, does anybody know what happens to this guy? Move to the left by how much? C degrees. Yeah. No.
Move to the right.
Yes, move to the right. Moves to the right by C. So I'll show you. Sine x minus 1, we'll say. Radians, this is radians. So it's moved to the right. So.
There's one situation.
Say again?
There's one situation that outside, right?
There's one more left, yeah? Well, 2 more left.
So it's like changing the sign.
Opposite, yeah.
What time is this already?
14. Right, 4. Y equals sine x plus d.
Move up by D.
Yeah. So, for example, yeah. Zoom out. Oh. Moves it up. Okay, got that?
So D will be zero. Technically.
In which one?
In this graph.
Oh, well, in this one, D is like, oh, I don't know, 3 or something.
No, I meant like we start at D. The sine graph starts at D.
Yes, you could think about it like that. It starts at D. But I have a different way of thinking about it, which we'll do in a moment. The last thing is minuses. So if you have a minus sine x, the effect is to take the graph and flip it upside down. And what about if you had a minus on the x? Does anyone know what happens here? Flips that way around, yeah. So it's like this. I'll try and show you here. Watch. Right, there's sine x. Now here's minus sine x. And then there's sine x. And then here's sine of minus x. So it flips it around. It looks the same, yeah.
Isn't it the same?
Yeah. Like with the sine graph, when you spin it around that way, it looks like it. Now, hang on, let me just show you it by itself.
Now, can you put sine negative x on?
Yeah, minus sine x.
That will be sine x, yeah. Let's do it. Minus sine minus x. So you go flip, and then flip, and you're back at the start. Yeah.
Could you
Sine
put?
negative x is equal to negative sine x.
Yeah.
Correct. Yep,
Would
that's a
that-
rule we'll do in semester 2.
That also applies to cosine and tan.
No, actually it doesn't. So if you look at cos, if I type in minus cos of minus x, if you flip it upside down and flip it around, do we get back to the original cos graph? No. See?
So it's from the bottom.
Yeah.
So sine.
It's a special for sine. Yeah. Yeah. Mhm. Yeah, so look, I just think of it like this. It flips it this way and it flips it this way. Yeah.
Show us the minus cos, negative cos negative x,
Yeah.
and cos x.
You want to see them side by side? Yeah, so here's cos x. That's what you asked me for, and here's cos x. They're not the same.
So they're still inverse, like they're inverse to each other.
Minus cos of minus x looks like it's just an upside down cos.
Yeah.
Mhm. Yeah, but I need a question. You know? Like if you are in your GPS, you tell it where you want to go. You know, you don't say, help me out here. So what is your question? Yeah, so look, there's sine x, okay? Now if I put a minus in the front, the effect is, you need to visualize it, you flip it upside down. So instead of going up, it goes down. Instead of going down, it goes up. So there it is there, okay? Now, let me go back in time. If I put a minus in front of the x, The effect is to flip it this way around. So let me show you. Okay, I'll just add a bit more here. So look, here we go right and up. But if I flip it around, we'll go
Down.
left and up. So it's like a mirror. It's like a mirror image. So here it's going down, so on the mirror side it's going down as well.
Down.
And then here, if you can imagine a mirror image of this on the right, it would look like that, wouldn't it? Yeah, well that's what we're saying. Like what's interesting about sine is that minus sine x and sine minus x make the same graph. It's not the same for cos and tan. Might be the same for tan actually. Let's check. So we want to see if this takes us back to tan. Yeah, it does. Yeah, it is the same. So you get the same effect with tan. As sine. Yeah.
Sorry, one question.
Yeah.
For cos, negative cos x, this is the same thing as negative cos negative x.
Yes, it is.
Yeah.
Yeah. Yeah. Okay, so look, we've talked a lot about this. Let's have a look on the question of how to graph this. Let me delete all this. So in the exam, they'll give you something to graph. Let's use radians since I've been using degrees, okay? So we'll say something like y equals 2 sine 3x minus pi over 2 plus 1. And they want the graph of this. Okay. Now the first thing you need to do is you might think, oh, it's fine, I have a sine bx plus c plus d. But the problem is, when I was talking earlier about the b, where did it go? Here. Now look, this is an important point, okay? This b has the effect I just described as long as it multiplies the entire angle. Now if you look back in my situation, it's only multiplying the x, okay? So before you start this question, there's a little trick you have to do. You want to make that b apply to the whole angle. So you can simply do that by taking out the 3. And now it applies to the whole angle, so it has the same effect that we were looking at. So this is x minus pi over 6. Now it is correct to identify this as A, this is B, this is C, and this is D. So, I'll start now in a moment. I'll just let you write this down. So you need to pay attention carefully, because I find the best way to graph this is with the help of a table. Okay? Okay, can we start this one here? So, this is the way I think about it. I draw a table, and I consider the effect that the A, the B, the C, and then the D has. I consider the effect it has on where I start the graph, where I end the graph, what the minimum point is, and what the maximum point is. So, let me just make that a little bit neater, sorry. I'll draw in start, end, min, max, and then the effect the A, the B, the C, and the D has. Oh, flip. Okay. Right, so look, we have a sine graph. So just forget about A, B, C, D for the moment. Just forget about A, B, C, D. If I have sine, it normally starts at 0 and then it finishes at 360. If I'm using radians, where does it finish? 2 pi. Now, think about the sine graph. What's its lowest point? Minus 1. And its highest point? 1. Okay, so that's just a plain sine graph we did at the beginning of the lesson. Now, let's consider the effects of A, B, C, D one by one. So, A, think back to what I said the effect of the 2 is. How does the graph change if I have a 2? It stretches. So, is the starting point affected? No, it still starts at 0. Is the end point affected? No, it still finishes at 2 pi. The minimum and maximum are affected. How so? Minus 2 and 2. But these are the same. Okay. Now, let's consider the effect of the B. So what is the effect of having a 3 here to the graph? Compresses it by 3. So, does it still start at 0? Yeah. But will it finish at 2 pi? No. It'll finish sooner. It reaches the end of its first cycle where? 2 pi over 3. Okay. Is the minimum affected? No. Is the maximum? No. Okay. Right. The C. What is the effect of having a minus pi over 6? I know you're thinking of D.
Right, pi over 6.
Move it to the right by pi over 6. So does it still start at 0? No, where will it start? Pi over 6. And here it will finish pi over 6 later, which is, what's that, 10 pi over 6? No, sorry, what's that? 5 pi over 3, is it?
To do these radians.
1 sec, yeah?
To do these radians now, do I need to change it to radians, or is it fine to just, because just degrees?
No, this is all in radians.
Yeah, no,
Yeah.
in radians.
Yeah.
Do I need to change my calculator more to?
Oh, no.
Yeah.
Yep.
Thank you.
Why don't you distribute the 3?
No, I don't. I deliberately took the 3 out because the discussion I had earlier about the transformations, it only works if the equation is in this form, where the B multiplies the entire angle, not just a part of the angle.
I think it's 5 over 6.
It's 5.
Oh, sorry, what is it?
5 over 6.
5 over 6 pi. Okay. Is the minimum affected?
No.
And the maximum? No. Okay, now what's the effect of the plus 1 at the end? Yeah, they're affected. So this is the same. This is the same. But what is this now?
Minus 1 plus 3.
3. Okay, write this table down and now I'll show you how to graph it. To what though? You didn't write this down? Dude, no. Come on. Oh. There, come on. Have you got it? Okay, please write this table down. We can go to the next part. Who's talking? Yes. I added pi over 6 to 2 pi over 3. Now they did on their calculator, so I'm trusting them. I think that's what it is, yeah. Okay, continue? Not yet? Okay. Continue? Yeah. So look, I care about the last row because the last row has considered the effect of all of them, A, B, C and D. So I'll just take them off the screen and it's the last one I care about here. Okay, for my sine. So please watch carefully for what I'm about to do. I'll draw my x and my y. There's x. There's y. Okay. Now I'll go as far as I'll go as far as 2 pi. Why not? Okay. So let's see. I'll mark here. This will be pi, and here this will be 2 pi, and this will be minus pi, and this one here is minus 2 pi. Now, if you look here, this is pi over 6. So because I'm dealing with pi over 6, to me it would seem appropriate to go up in units of pi over 6, okay? So this here is pi over 6, 2 pi over 6, 3 pi over 6. Do you get what I'm saying? So let me just pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, and then 6 pi over 6, which is pi. And then you can do the same thing here. 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6, which is 2 pi. 1, 2, 3, 4. Yeah, I'm regret.
What is right of pi over 2?
Ugly. Okay. Anyway, don't worry about that just yet. Okay. What scale do I need on my y-axis? So what's my biggest value I have? 3. So I think I'll just mark it up to 4. I'll go 1, 2, 3, 4. 1, 2, 3, 4. So there's minus 4 and there's 4. I know, but I'll make it symmetric so it looks pretty. Okay. Right, now the next part. So, pay attention. To help me draw this graph, I need to make a construction box. A box that will act as a guide to help me draw it in, okay? So, what I do, taking out my ruler and my pencil, I mark off the start, pi over 6, which is this dot here. So just with a light pencil, I'll mark in like a line here, going through pi over 6. Then I mark off where it ends, which is 5 pi over 6, which is here. Okay? Now, I mark off the minimum, which is minus 1, which is here. And then I mark off the maximum, which is 3, which is here. Okay? Now, what I do next is I take my box I just made, and I split this box, can you see this one here? Into quarters. So, I split this box here into quarters. So look, it's 1, 2, 3, 4 units long. So if I split into quarters, I have a line here. And then, how wide is it? 1, 2, 3, 4 units on the x. So if I split it down in the middle, it will be here. Now, if I think back to my sine graph, when I drew my sine graph, did I start in top, the middle, or the bottom? The middle, didn't I? I started in the middle, and I went up and down. I do the same thing in this box. I start in the middle, I go up, down, and then down, up. And if I want more, I copy, paste. So I take this box, and I copy it, and I paste it beside it, left and right. So my graph will look, oh, well, you get the idea, will look like this. Now let me draw it beautifully for you in the graphing program. So can you just read out the original question? What, well, flip's sake, what?
2 sine.
Hang on, something went screwy here. Let me open it again.
And that's minus 2.
Why did you put in quarters?
Hang on, let me just draw a bit more. 1, 2, 3, 4. Hold on.
Did you graph it? I didn't get the same thing.
Right, can you read out the graph? What was it? Y equals 2 sine, the original.
Yeah.
3x.
3x minus 5 over 2.
Yep.
Plus
Okay, let's have a look. This is my graph. Okay, let me zoom in a bit. There we go. See? Peaks at 3, like my one does. Goes down to -1. I didn't continue it to the left. So down, up, like that. Yeah. Matches up. I'm just a bit more zoomed out here. Let me zoom in a bit. There we go. Identical. Okay? So, if you had a cos, there's not much of a difference. What's the only difference if it's a cos? Well, when you get to the part where you draw your box, what would you do differently if it's a cos?
You start
at the top, go down to the bottom, and back up to the top. That's the only difference if it was a cos. Now, this is where the advantage of having the graphing calculator comes in, because you can check if you got the right answer. Okay. At 0, I believe it does. Yeah, because how big is my box? I said it's 1, 2, 3, 4 units, and 0 is 1 unit to the left. So this point should be the mirror image of this point, which is 1 unit to the right. Yeah, so it does exactly meet -1. Anyways, if you wanted to know the answer for certain, you could simply take your equation and sub in. Sub in x is 0, and you do get -1. So you could have a definite answer if it crosses -1 when x is 0. Okay, so I'll let you try these for a couple of minutes. Really, for the exam, they only ask you to draw sine and cos. So it's kind of enough if you can do A, B, C, D in question 1. So 1 A, B, C, D. Can I close this?
0.
Wait, okay.
0 should be minus.
Okay.
Second calc.
So what do I do? Second
calc.
So if I today zoom into the graph,
Yeah. Press zoom. It's better getting that. Zoom in.
Oh, that's an interesting one. We don't have to know how to graph that, but roughly speaking, the only difference between sine squared and sine is that sine squared is always positive. So instead of going up, down, up, it just goes like the letter M, you know. If the shape is a little bit different as well. I think with the sine squared, you know, if that's sine, I think with the sine squared, it's perhaps, it's like a little bit skinnier maybe. I'll have to think about it. But it's basically just like this. I can close this, Michelle? Yeah.